Hey, what's up, guys? John here again. So today, let's take a look at this week's weekly contest problem, the last one, number 1531. It's hard to believe, over 1500 problems on LeetCode now. Okay, so it's a hard problem. So string compression number 2. I'm gonna give it my own upvote. All right, you're given a string, and the way the string compression works is if you have more than two, no, if you have more than one continuous characters here, it will be converted to the a plus to the character plus the integer after it, right? For example, the a will become a a2, and a will become a3, and a lot of a's will become a maybe 12. Okay, something like this, right? And if there's only one a here, it's just a. We're not adding ones after a single character. And the tricky part or the hard part for this problem is that it gives you another letter k here. Sorry, another integer k here, and it asks you to remove at most k in this case. Basically, you're allowed to remove at most k characters, and then you need to calculate the minimum length after removing the most k characters, right? Well, actually, it's it doesn't really matter because the I think at most the k, to my understanding, it's as if the you're asking to remove exactly k's characters, because the more you remove, the smaller the characters will become. That's for sure, right? So if you can remove like k's characters, there's no point of only removing k minus 2 or k minus 1 characters, right? By removing more characters, you are definitely reducing the final compressed string's length. Okay, so that's that. And I think this problem is obviously a DP problem, but it's not a easy one. It's hard to come up with the state transition function here. So let's take a look. How can we approach this problem, right? And so the way we are defining our DP here is we are defining like a DP start and K. Okay, so start means that's the starting index, and the K is the from start at this current index, we can remove at most K. And what's the minimum length we can, I mean, what's the minimum length, right? If we start at 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 the start index and we still have K characters left that we can remove, right? So mm, okay, and let's say for example we have a a a b b c. Okay, so let's say the start is from 0, right? And basically the end result will be starting from 0 and the result is k. Okay, starting from 0 and the k is the k. Okay, right? So the key point here is we uh we starting from the starting point and we just loop through to all the way to the end. Okay, and so the way we are doing it, we are always keeping, basically we're trying to to maintain, let's say from start to j. Okay, let's say j is our looping point, right? J is from the start from start right, something like this, right? So we're trying to loop through everything from start to end to end here. And okay, from start to j, we're trying to keep this range to be the same, to have the same, yeah, to have the same characters, right? And in order to keep that, let's say the j is somewhere here. Let's say the j is here, okay? Right, this is j. So in order to keep from 0 to j and to be the same characters, we have to somehow remove certain letters, right? So in this case, we can either remove a's, 3a's, or we can remove one b's here, right? And we basically that's why we are always going to remove the lesser ones. Basically, we're always keeping the most frequent letters in this range, and we're trying to remove the less frequent letters, right? And after doing that, right, basically starting from here, we can just hand over the rest to a sub problem, right? The sub problem will be the dp j plus one, right? The j plus one. But how about the k here, right? So the k will be the k minus the ones we will be removing here, right? Remove. Basically, this k, the updated k will become to keep from start to j, right? How many to keep the start to j to be the same, to only include the same characters, right? And then how many letters we need to remove, right? Okay, so basically that's the basic idea of this DP problem, is to try to keep this groups with one letter, because that's the optimal solutions we can take here. I think there is a like DP plus. I feel like there's something like a greedy concept here. And now I think there's another tricky part here, is that I was totally confused about this part. I didn't know can I handle this case. For example, this one here, right? Right, A, B, B, A, right? So as you can see here, so the optimal solution in our case is going to be to remove the 2B here, right? Will be remove 2B, and after removing the 2B, will be basically this AA will be combined, right, to a new one. So the final answer for this one will be going to be A4 in this case, right? So I was like really struggled with how can I handle this case. Okay, after removing this, okay, do I have to get the left part and the right part and then combine them some together and do some like merged logic? But I didn't. Yeah, and then I just went that way too far, and I didn't I didn't end up well basically. But if we keeping this strategy here, right? Basically, we're starting from let's say the start is 0, right? Start is here, and the end is here, right? Basically, the j will be basically try each of the numbers here, right? And we're trying to keep maintaining the j's, maintaining the start to j as the to be the same character. So for example, let's say if we are at j is at a here and also at a, and we see that, okay, so for A and A, in order to keep those strings to be the same, we don't need to remove any character, right? So basically, we can pass this j plus 1, the k will be 0, basically will be the same. And then at the front here, we'll be calculating some of the current, basically the current length will be the a plus whatever the count we have here, right? So it's going to be a2. So the length will be 1 plus 1 will be 2. So 2 plus the rest here will be the total length for the j at this a here, right? And then we move j one more to at b here, right? So now we move j to here. And while we're moving these letters, these pointers to the right, we're also keeping like the count of each of each characters here, so that we can know which the most frequent letter, right? And then we will decide, okay, we will keep that many letters and we'll remove the rest. Okay, and now we're at B here, right? So we see, okay, so to keep this AAB as the same as OA, we have to remove one characters here, right? And then someone may ask, okay, so in this case, okay, if we remove, let's say if we remove this one here, right? And then we are assuming the rest will be the second part, but then this B is part of this B. So after this DP, right? After this DP, so this DP result can somehow like also get merged with this previously calculated result. So at this moment, this one may not be the correct final answer for this branch, right? Correct. Yes, you are right. So because we're always assuming whatever we have here will not get merged with the remaining DP subproblems. That's our assumption here, right? So you're right. So in this case, so this B will be split into two pieces. But remember, the J will keep increasing, right? So the J will eventually move all the way to the end, right? So when the J moves to here, let's say when the J moves to here, right? So in that scenario, right? In that scenario, we'll see, okay, so in this case, we need to remove two B's, right? So that we can make like three A's as the same as a group with all A's here, right? So in that case, even though the previously one is not the correct one, but later on, this scenario will be covered by the later J. That's one of the clever idea here for this logic here. It can automatically take care of this kind of like merging case here, because we're assuming because this j will be keep moving, right? And every time when we have a new j here, we'll decide what are the characters we need to remove. Okay, I think with that being said, and yeah, let's try to code these things, and maybe I'll try to explain a little bit more along the way, yeah, while we're coding. Okay, so like I said, we're gonna define a DP, right? The DP, so it's gonna be start and K, right? And then a few simple things, and it's gonna have an N here. We're gonna define a few variables to help us um, finish do the do the coding here. So basically, at the beginning, 0K, right? That's our starting point, right? We start from 0, and we want to see from 0 and have K remaining characters we can remove. What's the minimum length we can get here? Okay, and so here let's see, we have a few. Okay, yeah, first always, right, if the start K is in the memory dictionary, we simply return this memorization with start and K, right? So and then we're gonna have the answer here, right? So the answer, since we're getting the minimum, we're initialize this one as a maximum, and then we need another like dictionary, like I said, to keep count of all the characters have been have been seen, right? So in this case, I'm gonna have like a count equals default dictionary, right? And gonna be int. So and I'm gonna have a most frequent, okay, as to 0, right? So and then now for j, okay, for j in range start to n, right? So what do I do here? So first I will get the character here for the s to j. That's the current character. So first what I will do, I will updating this count dictionary here, right? Okay, so that's what I'm asking. I'm maintaining here, right? I'm maintaining like a counting dictionary for each for the for this range basically, right? I mean for the current, yeah, not for the for everything here, until this j point, because for the rest we don't know, right? We only care about the characters we have seen so far, okay? And and then I'm gonna update, right? This request re most free frequency, most frequency, okay? Most frequency, okay? And the max, right? Most frequency dot count c, right? So every time we have updated count here, I will check, okay, is this the current count the most frequent count so far? If it is, and then I update. Otherwise, I just don't update. Okay. Now, okay, so now we have the most frequent count here, right? And then we can what we can do? We can calculate, right? With this most frequent count, that's the okay. So we know that's the letters we want to keep, right? Basically, that's the letters we want to keep, and we want to remove all the rest letters, the characters, right? And with this many letters to keep, what's the length, right? What's the compressed length? So basically, the compressed length, right? For us to uh, keep this many letters, right? Is what? It's one plus, right? Okay, so it's one plus because at the big so this one represents the letter itself, right? So from A to Z. So we always need a one first, and then basically the length of this number, right? If it's 10, then it's 2, right? If it's a 100, then it's 3. So basically we just need to get the length of the string version of that, right? Free okay, frequent frequency. Yeah, frequent. But there is one special cases which is 1. So if it is 1 here, we're not using 1 here. We should using 0. That's why I'm gonna have like this one here. If this one mm, if right, if most frequent is greater than 1, right? Else 0, else empty basically, right? Sorry, else empty, right? So we only use the length if the length is greater than 1. Else we just don't add anything. Oh, sorry, not else 0. Yep, because we're keeping the length here. Okay, the compressed length for this sequence here. And then since we have that, now we can update the answer here, right? Basically, the answer is gonna be the minimum, right? Since we're getting the minimum of that of the answer plus what? So first we have this compressed length, okay? Plus what? Plus the dp, right? So now the dp, the rest will be starting from j plus 1, right? And then what else? So now the case, right? So the k, so what's the remaining characters we can remove, right? So to keep this one to be the most, to I mean to maintain the most frequent letters here, we have okay. So first we need to k minus something, right? Minus this thing is inside. So how many characters we need to remove in order to keep this many characters, right? So mm, so in this case, it's gonna be the current total length, right? It's the uh it's a j minus start plus 1, right? So that's the total length, right, of the current range, and we just need to minus the most frequent cost frequently appears the count of the most frequent letters, right? So that's the letters we will be removing, right, to keep this one here. And yeah, so that's that. All right. Okay, so the rest will be just some basic model, basic template thing here, right? We simply return the answer here, right? And remember for the for this DP, for this recursive with memorization solutions, we have to define like a base case here, right? So because we are keep doing this, right? We keep doing this j plus 1 or k something. At some point, this start and k, they will be reaching some invalid state, right? And that's why with these top-down solutions, we have to do some check. Basically, we have to define some base case, right? So what's the base case? Mm, let's say if the start is greater or equal than or greater than n minus 1, right? So if the start is greater than n minus 1, it means it's at the last it's at the last character. Or mm, sorry, it's not at the last character. It's out of the boundaries basically. If the start is out of the boundaries, right? Because we are keep adding the j plus 1 here, right? And we are looping through everything until the n minus 1. And when the j is n minus 1, and when we do a j plus 1 here, it will reach to n, right? Okay, so basically we can just do a if start equals to n. We do what? We do simply return 0, right? Because it is a valid state, but basically it means that for the current one is the G for the current compressed length. The rest we don't need to there's no sorry there is no mm, there's no remaining characters, so that the length for the empty string will be 0, right? So that's one of the the, the base case. And I believe if we just run it will throw it won't work, I think. Most free I think we okay. So I think another uh, yeah, I think so. This one, the basic idea is this, but it's this one, but the way it's not correct is because we're still missing some of the boundary check here. let's say, for example, here, if the n minus start is less than k, okay? So what does this mean? It means that so n minus start is the remaining is the range of the current substring, right? If the range is still smaller than k, it means that we can simply remove everything from this substring here, right? So that we can simply return 0 because after removing everything, it's still so the length will be 0, right? Will this work? Nope. So I think that's not the issue. I think the issue is uh I think the issue is this. So let's see here. So the issue is we have to somehow, somehow this k minus this thing will be negative, right? Basically, if this k is smaller than 0, there it shouldn't be a valid. That's not counted to be a valid branch, right? So what we can do here, we can do a if k. We only continue if the k is greater than this, right? Not smaller than this, and then we do this. Otherwise, we'll just stop. We'll just stop here. Okay, let's try to run it again. Yeah, so this time it works. And the reason when this case is greater than this, we don't do this. We need to continue? Because the next time when we see another j here, right? Another characters here, the most frequent count might got changed, and this condition might be might be satisfied, right? So in that case, the later scenarios may also need to go into the subproblems branch. So let's try to submit it here. Yeah, so it works. Okay, so mm, just to recap this problem one more time. The key idea here is that with the current state, the starting point and the k, we're trying to maintain from start to j as one group which only contains one letter. And to make that happen, we might need to remove some of the letters. That's why we're maintaining the most frequent count we have seen so far. And we'll remove all the letters other than the most frequent letters. That's why which means we are keeping these most frequent letters. And that's the length to keep the most frequent letters. And then the rest will be handing over to the next sub problem, which is starting from the current j plus 1, and the remaining k is this. Okay, so that's the basic the basic idea here, and some and some like a border edge case, the base case to check. One is the if the start equals to if the start has x has it's outside of the boundaries, we return 0. Or you know what happened if I remove this? Would it still work? I'm assuming I'm hoping it should still work. Mm, no, output 1. Yeah, I think for this case, yeah, mm, Yeah, there are some like edge cases. See for okay, so for this case is if we don't have this check here, because in this case it's the length, it basically falls into this scenario, right? If we don't have this, basically it will go to here, and it will try to do a count here, right? And then for J here, yeah, and to start, we're starting from A here. There's only one character here, and this is one, right? So we have one here, and the most frequent is also one, and the compressed length is also one. So we have a one here, plus this thing is zero, because once we do a zero plus one, it will be reaching the end here. And in this case, okay, so the final answer will be one, instead of zero. Yeah, that's why we need this check here, because because the for loop here is assuming the k it's smaller than the range here. That's why we have to try all the possible ways, right? If the k is even greater than the current range, there's no point of doing this all the for loop here. We can simply return the zero. And we also failed if we didn't have this check. So what's this check means, the basically if you have removed too many characters, right? Basically, if you remove um, you have used all the case, and you still couldn't keep the current substring as a to be the one, and then we don't treat that answer to be a valid answer. Okay, yeah. So that's why we need this check here. Otherwise, that invalid answer will be giving us the incorrect final result. So yeah, I think that's pretty much I want to talk about for this problem. Yeah, I know it's a hard problem. I didn't solve this problem during the contest because I got so confused about this part. I was trying to solve this thing like the how can I do a merge, and I also was having a hard time coming up with these techniques, because this is because you have to find out a strategy, right? A strategy to somehow approach the problem. And the strategy for this problem is to try to keep the left part. Basically, basically we have a b b c d e something, right? Basically, I think for this problem is we're trying to to split, right? Trying to split this whole string, assuming we start from zero, right, into two parts, right? And for the left part, we're trying to uh, we're trying to do a greedy way. We're trying to make the left part an optimal solution, right? Which will be we want to compress the most frequent letters, right? So that we can make the left part optimal, right? And then once we have the left part optimized, and then we can handle the rest to another DP subproblem here, right? The DP problem here. So, and we have to try all the possible, split here, right? Because we don't know which one is the correct one. Okay, that's why we have to try split here, 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 and all the splition here, right? And among out of those partitions, we'll get a minimum answer. Right. So yeah, I think one of one of the learning point, one of the point I learned, at least for me, from this problem is the and even though you don't have a clue about how can I solve this problem, you have to make a guess at least, right? So for this kind of string problem, basically the a common strategy is you have a range, right? And then you try to split the string into all possible substrings, right? And for this, if once you have split the string into a two parts, you have one part left on the left side, and you have to get the optimal solutions for the left part first, and then you hand the rest to the DP recursive calls. And another tricky part for this problem is that once you have the left part, what's the strategy, right? What's the strategy to make this left part a optimal solution? In this case, it's the we try to compress the most frequent letters. That's the that's our strategy to approach to make this left part an optimal solution. Okay, cool guys. Yeah, I believe I should stop here. Yeah. Yeah, okay, cool. Thank you so much for watching the videos and stay tuned. I'll be seeing you guys soon. Bye bye.